a chemist is working in the lab, oftentimes he or she will react two different reactants together. And we'll start with a certain amount of the first reactant and a certain amount of the second. It's important to understand which reactant will run out first and which reactant will be in excess, meaning there will be extra left over. So what the chemist will do is solve a limiting reactant problem. The limiting reactant is the reactant that runs out first. So our job in this type of problem is to figure out which reactant runs out first and is the limiting reactant, and then theoretically how much product could be yielded. So let's take a look at this problem. In this problem, we have 225 grams of phosphorus trichloride and 123 grams of water. And the question is, which one will run out first as the limiting reactant, and what would the theoretical yield be of the phosphorus acid, which is H3PO3? Let's get started. The best approach to this problem is to set up two scenarios. So I'm going to draw a big line cutting the board in half. In scenario number one, I will assume that phosphorus trichloride is the limiting reactant. I'm going to put LR for limiting reactant from now on. So let's assume this is the limiting reactant. We start with all 225 grams of the PCl3. I go through our stoichiometry as usual. First thing we do, convert this into moles. Molar mass of phosphorus trichloride is 137.32 grams. Okay. We make sure that our units cross out, and we are left with moles of PCl3. Okay. I'm not going to stop in between each step. You certainly could if you wanted to. Now we have moles of PCl3. Next step is to use our mole ratio from the balanced equation. If we take a look at that mole ratio, we want to know about phosphorus acid. So that will be in our numerator. And the coefficient for phosphorus acid is 1. Now for every 1 mole of H3PO3 that forms, we would need to input 1 mole of PCl3. What we will do is stop here and determine how many moles of our product we could form in scenario 1. The answer for scenario 1 is 1.64 moles of product, H3PO3. Now what we will do is we'll switch gears and we will then imagine a different scenario. Scenario 2 would be that water is the limiting reactant. And again, these are just hypothetical scenarios. Right now, we're not sure which one is correct. What we'll do is we'll compare how much product each scenario can make at the end. But let's get started using the water as the limiting reactant. 123 grams of water. Okay. We know that the molar mass of water is 18 grams per mole. So for every 1 mole of water, it's 18 grams of water. Make sure that the units are crossing out. Grams of water, grams of water. We're left with moles of water. Our next step would be to look up at the equation and look for the mole ratio between H3PO3, which is again what we're interested in. It's still right up here, 1 mole of H3PO3, but this is for every 3 moles of water. So this is a different mole ratio than scenario 1. It takes more moles of water to form each mole of phosphorus acid. So what we do is into our calculators, we will type 123 divided by 18, and then we will also divide that by 3. And the answer is 2.28 moles of H3PO3 could form. At this point, we have to decide which scenario is the true scenario that represents the true limiting reactant. So we compare the amounts of phosphorus acid that could form in each scenario. So in scenario 1, 1.64 moles could form, whereas in scenario 2, 2.28 moles could form. What this means is scenario 1 is actually correct. The scenario that forms less product is the one that is based upon the true limiting reactant. And remember, the limiting reactant is the reactant that you will run out of first. You will run out of PCl3 first. It will form only 1.64 moles of H3PO3, and then there will be leftover water, which is not a big deal because water is pretty easy for a chemist to deal with. So that's actually a good thing, practically speaking. What I like to do is once I determine which scenario is correct, I cross out the other one. I don't want to look at the wrong information, so I circle scenario 1 because it forms less product, which means it's correct. The limiting reactant is PCl3, and the theoretical yield of phosphorus acid is 1.64 moles. Now, typically we report our theoretical yields in grams, so I'm going to switch gears, and I'm going to pull up another slide so we can convert those moles into grams as our final step. As you can see, I've transferred over the information from both scenarios 1 and 2. We already determined that scenario 2 is incorrect. Scenario 1 is correct. So my final step would be to simply convert the 1.63 moles of H3PO3 into grams. Now the molar mass of H3PO3 is 82 grams per mole. We put the grams on the top because that's what we want. We put moles on the bottom so that they cross out. And our final answer with our theoretical yield is 134 grams of H3PO3. So that's it. We determined the correct limiting reactant. We based all of our calculations on that limiting reactant. And now we have our true theoretical yield. And this chemist now understands that 134 grams is the maximum amount of phosphorus acid that could be formed.